The next topic in our algebra review is exponents and radicals. This is section 8.3, and I'm marking it with a star because it's especially important for us to be able to use exponent rules and properties and simplify algebraic expressions. Once we start learning the calculus, we don't want to have to spend too much mental energy on simplifying things. So this section is very important for you to master these exponent skills and be able to simplify things rather quickly. In this section, we're going to talk about different types of exponents. We're going to talk about exponent properties and how to simplify using those properties. We're also going to talk about simplifying an expression by factoring out a greatest common factor, or GCF. And lastly, how to find the domain of algebraic expressions. Exponents come in many different types. The first type that we see most commonly is positive exponents. This is the property that says if you have x raised to any numerical power, and I'm just going to use p for power to represent any number here, what this means is x itself times x itself all the way up. I don't know how many times this would be, but whatever that exponent is there is shorthand for how many times you multiply the base by itself. So this would be x times itself p times. For example, if we really want to be specific about what we mean by saying something like x to the third power, that would be x times itself 3 times. When you raise x to the third power, it's not too hard to write it out 3 times, but when you start raising things to the 10th power, or even the 5th or 6th, it is pretty tedious to write that out, and who wants to count all of those? A zero exponent is probably the easiest exponent to raise anything to. If you have anything, I'll use x for that anything, raised to the 0 power, and 0 is not considered a positive or negative number, it is the only number without a sign, this is just always equal to 1. The only thing we have to note is that we can't have x equal to 0, because 0 to the 0 power is actually called an indeterminate form, and who knows if it's 0 or 1. We won't talk about that, but that is something that we need to consider. An example of raising anything to the 0 power, we can make this as complicated as we would like. Maybe it's x squared plus x minus 10 over x to the third plus 2. And if you just raise that to the 0 power, this is just 1. You don't even need to consider what is inside of those parentheses. The third type of exponent is a negative exponent. So we've talked about positive, 0, and then of course we've got negative numbers. So if you raise something like x, or any base, variable or numerical, to a negative power, so I'll use p for power here, this is actually shorthand for a fraction. So this is the same as saying that this is equal to 1 over x to the positive power. That's the same as 1 over x to the positive power. If you want to get rid of that exponent, we just put it in the denominator and make it positive. Now we need to be fluent going back and forth. So sometimes we will want to rewrite things without a negative power by going in this direction. And sometimes we will want to rewrite things not as a fraction, going in this direction. So we really need to understand that these mean the same thing. They're just, one is a kind of shorthand with the negative exponent. The other way might be easier to work with in some cases. An example of a negative exponent, if we have x to the negative third power, then that is the same as saying 1 over x to the positive third power. Here's another example, because sometimes we have a number in front of the variable when it's raised to a negative exponent. So maybe we have something like 2x to the negative fourth power. Now we have to be careful with what is allowed to kind of go into the denominator when we take away the negative exponent, or when we rewrite the negative exponent. So here, this negative 4 exponent is only on the x, right? We don't have parentheses 2x to the negative fourth. The 2 is on its own, and then it's multiplied by x, which is raised to the negative fourth power. So the x is the only thing that gets to go down into the denominator, and then we'll make its exponent of 4 positive, and then the 2 just stays up in the top. So if there's a coefficient or a number multiplied in front of a variable raised to a negative exponent, only that variable gets to go down into the denominator, and that coefficient has to stay up in the top. The fourth type of exponent has to do with roots. If we are taking maybe the square root of something, And I'll use x here as whatever is inside of the root, but it could be a number or a variable or any expression. And maybe it's not even the square root, maybe it is another kind of root. Like instead of p for power, I'm going to use r for root. So if we have the rth root of x, right, here's the place where we put this. If there's no number there, we just understand that that is the square root. Then this is the same as x to a power of 1 over r. So in our power, we have a fraction where the root is in the denominator of the fraction in the exponent, and we have 1 in the numerator of the fraction in the exponent. Now again, one of these is not necessarily simpler than the other, but generally we will prefer writing things this way because they are easier to work with and easier to use exponent rules on. But we do need to be able to fluently kind of, understand that this means this and that means that. They're meaning the same thing, just written in different ways. So for example, one thing that will commonly be converting from a root to an exponent is the square root of x. So again, when we don't have a number in the place where I put this r here, it is assumed that that is a 2 for the square root. So the square root of x can be written as x to the 1 over 2 power, or x to the 1/2 power. Okay, these mean the same thing. Again, sometimes it'll be easier to work with it in one form versus another. Here's one more example. If we have the root of x that is the 5th root of x, take a sec to write down what this might be. Of course, that is the same as x to the 1/5 power. So whatever that root is, that just goes in the denominator of the exponent, and we get a 1 in the numerator of the exponent. Generalizing the idea of roots being written as x to the 1 over r, the rth root, maybe inside of the root, I'll use r again here for the root. Maybe inside of the root we have a variable x, or maybe a number or anything in here raised to an exponent or raised to a power, and I'll use p there for that power. We can also convert this into an exponent and maybe make it look a little less clunky and have it be easier to work with. So instead of x to the 1 over r, we're still going to have the over r because the root is still the rth root. But instead of the 1, which actually came because we had x to the first here, in the numerator of the exponent, we will just have a p. So this is x to the power over root, or p over r exponent. Okay, so here's an example of this. If we have something that looks like the 3rd root, or the cube root of x to the 2nd power, this would be the same thing as x to the power, which is 2, over root, which is 3. So x to the 2/3 exponent. One more example, and you should pause this video and try to write this one on your own. Maybe we have the 5th root of x to the 4th exponent. What would this be rewritten as x to a power? Hopefully you remember that this is an fraction in the exponent, but you have to know, is it 5 over 4 or 4 over 5? And again, as always, power over roots, that should be 4 over 5, or x to the 4/5.